So here we go with quadratic equations with topic 1.1, setting the scene. So the first thing we're going to do is look at the origin of basic ideas. So what's the way of writing 5 plus 5 plus 5 plus 5 plus 5? Well, it looks like we have, 7 times 5 is 35. What's a way of writing 7 plus 7 plus 7 plus 7 plus 7? Well, we could say we have 5 groups of 7, which is 35. Okay, now look at the fast way of adding up these squares. To look at the squares, just count the dots. Well, you could sit there and go 1, 2, 3, 4, 5, 6, 7, but that would take you more time when the pictures are bigger. You could also consider that we have 3 this way, and there are, 6. So we look at 6 columns or 3 rows. So 3 times 6 as a rectangle, or the area of them, and there's 18 of them. My explanation was longer than counting from 18, but if it gets pretty big, we would need to, there's a fast way of sitting there as opposed to sitting there and counting all the dots. Okay, so look at this. So here's the first idea. We're going to get to this idea of trying to prove why a negative times a negative is a positive, so that we can use this for later applications. It begins with understanding the relationship between arithmetic, which is adding and subtracting, or basic addition, and it leading to the idea of multiplying, which, why would you multiply? What could be considered fast ways or efficient ways to calculate areas. So it says, what's the relationship between arithmetic, adding, or multiplying an area? Well, we can use multiplication to count up areas, or we can use area to represent multiplication. Now, this one says, show how to multiply 37 times 23 using area. I'm just going to move over this way. So there it is. And we're going to use 37 times 23. Well, we could consider it like this. There's 30 dimensions, or 30 squares, and then 7 more. We could also have 20 units this way, and then 3 more. Alright, so we can then draw ourselves areas of sizes. So this big box is 30 by 20 high. Well, 3 times 2 is 6, and then shortcut, add a couple zeros. 600. So this whole area here is 600. This segment here is 7 times 20, 7 by 20. So 7 times 2, 14, add a 0. Bam. And then we also can complete the areas here. This is 7 units wide, 3 units tall. Consider it like the previous one. 7 times 3, 21. And then we have this section over here. 3 times 3, 9. Add the 0 from 30, so this is 90. Then all we need to do is add them all up. Add all the individual values of all the parts squared. So we have 600. Okay, I would do 600 plus 140. Well, 600 and 140 gives me 740. Psh. Check, check, done. At 90 more. 90 is like 100 more, so that's 840. But less 10. So 830. So I just added 100, took away 10, done. Add 21. I'll just use stacked addition here. 0 plus 1, 1. 3 plus 2, 5. And lo and behold, as opposed to using a calculator all the time, we can get the multiplication of 37, or 30 plus 7, and 23, or 20 plus 3. So what I did is utilizing this idea of changing a number into a binomial, as in two numbers added to make that number up, 30 plus 7 and 20 plus 3. Now, what was important about the first belief, this one comes from the very, very first box above. Look at this. Bam. It's going to be fairly obvious that if we have one number, 7 times 5 is 35, but if we do it like this, 5 times 7 is also 35, well, that means they're both the same no matter which way we write them. And I will also explain that geometrically. So the first belief is that some number times another is the same as the other number times the first, and the order of which doesn't really matter. So if you go, for instance, I believe this is what's coming up next. 2 columns, so 2 by 3 rows. 2 times 3 equals 3 times 2. Okay, so it doesn't really matter if you do this way, then that way, or you could look at it as 3 rows of 2 or 2 columns of 3. If you add 2 columns versus adding 3 rows. Either way, it's the addition. Doesn't seem to matter the order which way you look at it. That's the chunk about this belief. A times B is the same as B times A. Next. Whoops, too fast. And, alright. Here we go. So, the idea is for you to practice, how would you multiply 15, well, so I guess let's just zoom in so you can sort of see what's going on here. Multiply 15 times 12 using area. Well, the idea is to make a binomial, as in A plus B, two numbers that add up to 15. You could choose 10 plus 5, your choice. And this one could be 12, makes up from 10 and 2. Well, then you just draw it area-wise, where you have 10 units, 5 more, whoops, scale's not proportional, whatever, 10 units, and 2 more. So you can, whoops, yep, figure out each area separately as a multiplication. 10 by 10, 5 by 10, 5 by 2, and then 2 by 10, and then add them all up. Show that you could actually practice that. Okay, moving along. So now we have these questions, which I've already showed in here. What happens if you have 2 by 3? Well, this could be the idea of 2 columns of 3, or three rows of 2. So you could have 2 plus 2 plus 2, or 3 plus 3. They're both equal to each other. 2 plus 2 plus 2, or 3 by 3 by 3. They're out of order that way. Now, what happens if they're negatives? And I said there's 2 times negative 3. Well, we could have 2 groups. We'll call these negative. You know what? We can change color. Make it typically negative is red, so we'll just do that. Okay, 2 groups of negative 3. Ready? 1, 2, 3. There's some negatives. And 1, 2, 3. Okay, there they are. There's the groups as of 2, hence the 2 times. There's 1, there's 2. So it's negative 3 plus negative 3. Therefore, we have how many in total is obvious visibly, negative 6. And then what if we went first and say, well, we got negative 2 groups of 3? Well, this is hard to count. But if we go back to our fundamental idea of the first principle, that A times B equals B times A, well, that means we can just change the order and to a 3 times negative 2. That means there's 3 groups of negative 2. So let's just draw those out. Bam, there's a group of negative 2, there's a group of negative 2, and there's a group of negative 2. And we've got 3 of them. 1, 2, 3. When I count that up, negative 2 plus negative 2 plus negative 2. And lo and behold, how many are there? Same as the previous one, negative 6. And we get to this one, negative 2 times negative 3. We have a negative times a negative. We don't know how to count negative 2 groups of something, so why don't we just try that reverse idea of B times A times B? Well, then we get negative 3 groups of negative 2, which doesn't really make sense. Okay, can't draw that, essentially. How do you count? This is easy to count the groups. This one you really can't to do the arithmetic. Well, let's see if we can do some other ideas. What we're going to do, because if we're left with a dead end here, so maybe we need to do some other ideas. We're going to show how to multiply 17 plus 18 using area. Okay, and watch this. We're going to do it 4 different ways. And this is going to lead to a proof. Again, 17 by 18, and we're going to get to a proof idea. We're going to do it this way. We're going to have a positive times positive, a positive times negative, negative times positive, and then we can make some conclusions about consistencies. So, remember our problem is 17 times 18. We want to make them both positive numbers. So the clear choice would be to go 10 plus 7 times 10 plus 8. We're going to have positive all situations. Let's go draw this out real quick. Area, geometrically, as we've been doing just before there. Could have used my line tool, but this is just as good. 10 and 7, 10 and 8. The 10 by 10 is 100. 7 times 10, 70. 7 times 8, scary, 56. And then 10 times 8, 80. Okay, so if you want to do the quick arithmetic, which is really important here, I would do these ones because I know that 7 plus 8 is 15. And there's 10 bigger, so it's like, okay, that's 150 right here, plus 100. Okay, so we're at 250, and then we have to add this little chunk here, 56. So we know this adds up to 5 times 10 and 306. So we know that 17 times 18 is 306. You can double check this with a calculator. I'm just going to move this chunk of stuff up a little bit. Okay, so we know that 17 times 18, 306. That's consistent. All right. Now we're going to do, I'm just going to do some erasing now. All right. Now we're going to do a positive times negative. Okay, so we get 17 times 18. We'll have the first one positive, so we'll go 10 plus 7. We'll split that into 2 terms. But we'll make this a subtraction. Well, let's go 20, take away 2. That's 18. Now I'm going to cheat. Makes my drawings. Whatever. And make it not perfect. It's just a representation, not a true rectangles. All right, 10 and 7, 20 minus 2. Well, the 10 by 20 is 200. Positive 7 times 20 is plus 140. How over here? Well, we have positive times negative. Well, we knew that if this is 7 groups of negative 2, that'd be negative 14. And if we have 10 groups of negative 2, we'd have negative 20, if we consider those ideas of this is the groups of. Okay, so we're at 200 plus 140, that's easy, 340, minus 20, we're at 320, take away 14 more, and we're left with the exact same total, 306, so 17 times 18, still 306. We have a positive times negative, and we also get this idea, positive times negative results in negative. We already knew that. Okay. Gonna do some more clearing here. I guess I gotta redo that. Oh well. Alright, so now we're gonna do the same thing with negative and a positive. Just gonna draw this out here. Stick to the grid for me this time. It's gonna be a little bit bigger numbers. Whatever, it's just a nice little grid. Yay. Okay, so we're going to make this one a negative, so this could be 20 take away 3. And this one could be simply back again to 10 plus 8. We can make it ever number if we want. We're just trying to get some ideas out of this. So 20 take away 3, and we have 10 plus 8. We already knew 20 groups of 10, 200. 10 groups of negative 3, minus 30. 8 groups, or 3 groups of 8s, or 8 groups of 3 is minus 24. And lastly, 8 times 2, 16, add a 0, plus 160. So low, if we do all the adding or addition up, 200 plus 160, sloppily, 360. Take away 30, bam, we're at 330, and then take away 24 from this one here, and we're back to the exact same answer, 306. Consistent. That means this must be always true. Now we get to the last idea. Let me just draw out my rectangle first. Because we know this is where we're going to use this area idea. 17 minutes. This is a big introduction, by the way. It needs to be. Okay, we're going to make this negative. So this would be 20 take away 3. And 20 take away 2. 2 subtractions. So we have 20 take away 3. Oh, by the way, we still know that this is 306. It's a very important idea. 20 take away 2. Well, 2 times 2 is 4, times 10, 400. 20 groups of negative 3, minus 60. This we don't know. We'll go over here. 20 groups of negative 2 is minus 40. So we check our arithmetic so far, and we want to know what is this answer, because we're back to that negative 2 times negative 3, which was our roadblock before. Haha. 400, take away 60, take away, I guess I should do that, 340, take away 40, we're at 300. We know the answer of 17 times 18, and the only way we can get 300 using this total, we have to add 6. And therefore we get 3 negatives times 2 negatives gives us positive 6. That's a pretty big idea. So we have proven with ways of multiple steps that negative times negative is in fact a positive. Okay, last one. Here we go. Show how to multiply 2x plus 1 times, shouldn't need extra times there, 3x plus 7. Alright, 2x plus 1, 3x plus 7, using area. 2x plus 1. I'll just go here. 2x plus 1. 3x plus 7. We'll use the area model. Okay, so we're going to say this is the 2x's, because that's just like that, and then plus 1, and then we're going to have 3x plus 7 area. All right, so 2 times 3 is 6, x times x, x squared. One group of 3x's is one group of 3x. One group of 7, just a 7. And then you got 7 groups of 2x. So plus 7 times 2, 14, and x. We gather like terms together. This is the only thing that has an x squared. This is called a Galley idea, but so we have 6x squareds. These two are both x terms. There's 14x and 3x, so we get 17x plus 7. So we multiply, review from before, we can take an area model and make it into a thing we've talked about before in Math 10 Common. Voila. Okay, moving on to this one. It says, what can you tell me about this rectangle that's 36? We have 36 units. And is there anything you can say about it? Well, it could be 9 times 4. So it could be 9 times 4. It could even be 18, 2. It could also be 12 times 3. It could even be 6 and 6. And it could even be, ready? Here's a weird one, 10 by 3.6. That would give 36 as well. So basically, unless we know anything about this thing, any more information, we can't actually say what the sides are. So there is one thing that we can utilize if we need to in the future, that if we want to actually make a claim, we need more information. And in fact, if we do this, then and only then can we answer the question of what it could be. If we could provide the idea of symmetry and cut this thing exactly in half, that means what that will do for us is make this equal to that. It's a beautiful little principle. And it will also give us that this equals this. And what you get is a perfect square. The only way that this makes it all equal is making a square, and then you can specify versus a rectangle. It's a type of square, or a square is a type of rectangle, but it will only give us then and point to one and one answer only, which is kind of nice when we need to work out future problems. So we're going to use that idea. I'm going to skip to the next one in a second. Okay, last one here is a farmer has 40 meters of fence, so it means you have a straight line distance of 40 meters. Okay, 40 meters is the straight line distance of fence. But, and it ends off one end to the other, but he wants to make a rectangle out of this. You got to bend it, okay? Bend it, bend it, bend it, bend it, and such that you get a rectangle. I'm just going to draw a rectangle really quick. Okay, 40 meters. So this is all around A, B, C, D. That A plus B plus C plus D all equals 40. Okay, that's all 40. And he wants to get the most space out of this. Now, if it's symmetrical, that means all this, if it's perfectly symmetrical, where it literally divides up, whoops, my lag delay. If this was symmetrical, that means A equals B equals C equals D, and therefore the lengths are all the same. That means 4 of any of the sides, whatever 4a's, is equal to 40. Divide by 4, you get every side would be 10 meters. If this was perfectly symmetrical, this would be 10. This would be 10. This would be 10. And 10. If it was a perfect square. Okay. So let's just make a change where we could change the length of each one. I'm going to need to do a little bit of erasing here, just a little bit. So now we have established that we have the biggest possible length for our rectangle. Okay? Has to be 10. We'll make it a rectangle, we'll make it a 10. Okay? So this is going to be 10. This is a 10. This is a 10. This is a 10. But if we want to change the length and try to make it bigger, you know, add some way this way, what we have to do is then subtract some stuff this way to accommodate that. Because if you want to make it bigger one way, shift the whole thing over. You know, trying to make it bigger like this. Well, you got to take away somewhere. Well, you got to take away from these two. Okay. So what we could consider is we're going to add some. Oops. Probably shouldn't use red. We're going to try to add some length. If we want to make it bigger, add this way. But what we have to do is actually take away the exact same amount lengthwise this way. And so what we get is a weird rectangle. Let's zoom out now. I need to do some erasing. We have the dimensions are now 10 plus x and 10 minus x. Let's just write that a little nicer here. 10 minus x, 10 plus x. Because if we want to make it bigger, we got to take away somewhere. And so this is what we get. Okay, what if we're considering the area? Well, I only need two sides to look at to consider the area. I already have the base. I already got the height. And if we just said, well, this is just going to be doing this. 10 plus x. This is 10. This is minus x down here. Okay, 10 by 10, 100. X times 10, 10x's. And then positive x times negative x, minus x squared. And then 10 times negative x, negative 10x. And lo and behold, we can get an expression for this area that we have 100 plus 10x, and then take away 10x's from over here, and then that just eliminates to 0, so you have 100 minus x squared is equal to the area of this particular space of this pen. So this is what gives the best possible, or the biggest possible area. Now, if we want the biggest, we want this to be we're taking away, so it's kind of obvious that we're taking 100 from x squared, or rather x squared from 100. So if we want the most, we want to take the least here to get the most here, because we're just subtracting. Well, what's the least you can take away? Well, we already knew every number by itself will become positive, so the least possible x is 0. Huh. So if that's 0, the most area it could be is 100. Interesting. So this is a way to get the absolute most possible area of a situation. That's it for this lesson. This will lead on to later, how did you get expressions for different types of situations in your homework and later extension problems. Thanks.